In this section, we're going to be talking about the application of quadratic function to a business problem, which is to solve for the quantity to maximize the profit. For-profit firms, their priority in business is to make more money, right? So that's why we seek to maximize the profit. So here are several things to note. The first one is total revenue equals to unit price multiplied by quantity. And here, total revenue is the total gain without considering the cost for firms. And the price is unit price. So each pen is $1 and you sold 100 pens, then you get $100, right? 1 by 100. So this is what we get for the first one. And the second one is profit, which is net gain, equals to the difference between total revenue and total cost. So after knowing that, let's go to example 2B1. So here we are given a demand function, inverse demand, and we are given a total cost function, and we are to work out the expression of total revenue, the expression of profit, find the vertex of Q to maximize profit, and the last one is to find the Q that breaks even this firm, which is the root of the quadratic equation of the profit. So let me note them down as I'm talking about this. Switch to my document camera. So here, the information that we're given is 600 minus 5Q. That's the first one. And the second one is total cost equals to 10Q plus 300. Okay, so these are the information that we know. And in 1, we are asked to solve for the expression that stands for total revenue. 2, we're asked to work out the expression of profit, which is noted as pi. Okay, that's the profit. And in 3, we have to find the vertex Q, right, that maximizes the profit. And in 4, the break even. And we're going to talk more about this later. Okay, so we have all those 4 questions noted, and now let's solve them one by one. So question 1, we have to work out total revenue. Okay, as we just mentioned in slide 2, total revenue equals to price by quantity. Okay, and this is not the end, because we can further clarify this. Right? What is price? So price is 600 minus 5Q by Q, and we can further simplify that. That's 600Q minus 5 by Q squared. So this is the total revenue. And note that here, Q is the decision of firm. Right? So, or under the control. Under the control of firm. Why do we say this? Well, think about this. A firm makes decision to tell its production plant, how much parts to assemble this year, right? So the firm's decision is on Q. And why does this matter? The firm's decision is, excuse me, is on Q. Then we need to have Q as the independent variable. Because total revenue then is dependent on how much the firm decides to produce, right? So we are expressing total revenue as a function of Q. So that's what we do. That's question 1. Question 2, we're asked to find the profit, and profit is the difference between total revenue and total cost. Okay, so total revenue as we found is 600Q minus 5Q squared minus total cost 10Q plus 300. And we further simplify this by opening the bracket. So we have 600Q minus 5Q squared minus 10Q minus 300. Right? And the result is 590Q minus 5Q squared minus 300. Or we want to rearrange it so that the power of Q is on a descending order. So like this, minus 5Q squared plus 590Q minus 300. Right? Why do we do this? Because the function format that you're familiar with is fx equals to ax squared plus bx plus c. So here it's the first term with the independent variable is of a higher order, power order, and then a descending power order to 1, a descending power order to 0. Right? So this c itself can be considered as c multiplied by 1 or c multiplied by x to the power of 0. So that's why I'm saying this is arranging in the descending order of the power for x. And here we are doing similar thing. Then you can find we express our profit again as a function of the decision of firm, which is quantity produced, right? And it is then easy for us to figure out, in this case, A equals to minus 5, B equals to 590, C equals to minus 300. We put it here for preparation of step 3. So in step 3, we are asked to solve for the vertex, which is Q star, that optimizes the profit. And here, it is helpful for us to draw the curve, the function curve, right? Since A is minus 5 here, smaller than 0, that means this quadratic function, the graph of the quadratic function is opening downwards, or parabola, whatever you call it, right? It's opening downwards, and then we are here to find the symmetry axial, which is the vertex. So the function of the vertex is minus b over 2a, and here we just take in those numbers. So it's minus 590 over 2 by minus 5. So this 2 minus sign get canceled, and the result is 59. So when Q equals to 59, the profit is maximized. And then here, question 4 is to ask you the Q that breaks even the profit. So here, I'm not going to talk about the detail of the solution. I just want to let you know, how do you understand this break even? Break even means no profit, profit equal to 0. So basically then what you are doing is to solve this 5Q squared plus 590Q minus 300, which is the expression of pi, right? That equal to 0, you're solving this quadratic. And the root, there could be 2 roots, and probably one is smaller than 0, one is greater than 0. Then the one that is greater than 0 should be reported. If you have 2, then if you have 2 positive roots, then you should report both. Okay, so here is the idea, the logic of setting up the problem and clarify the profit function, find the vertex, and find the root, which is, see, here and here. Those roots are for the break-even solutions. Thank you.